Hello everyone, welcome to another video. In my previous videos, I have already explained about neural networks, how do those neural networks work, their classifications and their architectures as well. In this video, I'm gonna portray how to write the Python codes for an intended neural network model to get to the output. So there are several steps to reach the output if we want to compute the intended neural network model. So the steps are, firstly we have to import the library. Then we have to load the data sets. Then we have to create the intended neural network model, and then we have to compile the neural network model. Then the next step is to actually train the neural network model, and the final one is the evaluation of the model. That is the output. That is getting to the output actually. Yeah. So in this video, I'm gonna show how to write Python codes for the implementation of the neural network model, of the intended neural network model more precisely, and in several steps. So first, in the beginning, I will show the step-by-step Python codes. I write the step-by-step Python codes rather for a basic neural network model. Then I'll write the Python codes for several neural networks such as recurrent neural network models, recurrent neural networks for sequence prediction, and then autoencoder for anomaly detection, convolutional neural networks, then codes for GRU for text generation and all, etc. So I will write those codes. I will write those Python codes to get to the output for a particular neural network model. So first, as I have told, I will start with a very basic neural network model. I'll write the codes for that. And one more thing that I want to mention here, I will be using the very popular deep learning library, that is TensorFlow Keras. Okay? Well, so let's begin writing the coding without wasting time. Well, so firstly, let me tell you, if the TensorFlow library is not installed on in your system, then please do install it by writing pip install TensorFlow, and then we will be importing the libraries. So this particular Python code that I'm gonna write or show you people is for a basic neural network model. We will delve into other neural networks, that is convolutional neural networks, the RNN, that is recurrent neural networks, the autoencoders, the GRU and all in the later part of the video. Well, so let's begin with the basic neural network model. Let's write the code. So for that, firstly we have to install the TensorFlow, the deep learning library TensorFlow. If it's not installed in your system, so let's begin with the basic one. So this is the pip for installing So as you can see in the screen, this is the Jupyter Notebook interface that I've already opened here. So you have to just write the prompt Jupyter Notebook command Jupyter Notebook in the terminal, and it will automatically prompt you to this type of interface that you can see on your screen. So let's begin with this. So let's first let's install. I'm not gonna install this actually in TensorFlow. I'm just showing it which commands we need to write. How to write the Python codes and in a step-by-step manner, and you will be getting all the details here. So this is pip install TensorFlow. Okay, so this is the TensorFlow. This is the deep learning library TensorFlow. This is a very important thing. We'll be using this thing when you will be in these codes. Okay, now you have to install this thing, and then you have to write the code that I'm gonna write. Okay, you have to import all the things later. So the idea is, so I'm not gonna install these things. I've just written this code just to show you people which command to write, which code to write for the installation of this TensorFlow, the deep learning library. Okay, let's head to the next part is basically importing the libraries. Okay, so let's import the libraries. Let's import the required libraries. Well, yeah. Now the required libraries are like this. So for that I have to abbreviate the term TensorFlow STF, since it's a big word. So I have to use this term so many times in this code. This is going to be a very long code. Not very long, but it's a moderate size code. So I don't want to use this word time and again. So I'm just abbreviating this thing. So import TensorFlow STF. Okay, you can see this code. You can write A, B, C, D, E, F, G, whatever you can write here, because you're just abbreviating this thing because you're gonna use this particular thing. So if you write X here, so you have to use X if you write X later on in this code, that will ultimately lead us to TensorFlow. So the next part is I have to write from TensorFlow dot, follow this codes carefully. Now since this is the TensorFlow, the library is TensorFlow, the library is basically TensorFlow Keras. So I'm gonna write this thing. Okay, so this is TensorFlow Keras dot dataset, import MNIST. So MNIST is basically the dataset that we are gonna load later on. TensorFlow dot Keras dot datasets. Let's write it down. Keras dot datasets, import MNIST. Okay, well, now this MNIST basically, this is the data set. Okay, now here, so what I've written here, from TensorFlow.Keras.datasets, import MNIST. Okay, TensorFlow, so here TensorFlow.Keras is the library and dataset is the dataset. Okay, so that's the idea, that's why we have written like that. Well, so this is from TensorFlow.Keras.datasets, import MNIST. Okay, well, Now the next thing is that, now the next part is that we have to write from TensorFlow dot Keras dot models import sequential. Since we are gonna predict the the sequential prediction, so that's why we're writing like that. This is the from this is the code is this from TensorFlow.Keras dot models import sequential. Okay. Now the next part is that we have to write from TensorFlow.Keras dot layers import dense and flatten. Okay. So from TensorFlow.Keras dot layers import dense and flatten. Okay. So the next line from TensorFlow dot Keras dot layers import dense flatten. Okay. Yeah. So from TensorFlow.Keras dot layers import dense flatten. Okay. Now the next line will be from TensorFlow.Keras dot utils import to categorical. So the change will be here, the dot utils. Now from TensorFlow.Keras dot utils import to categorical. Okay. So this is the first part, the importing all the libraries. Okay, you have to write all the code, then you have to hit the enter plus shift on your keyboard, then you will go to the next input line. But I am writing all the codes in this particular input line. Okay, that's not the that's the thing. Yeah. So we have already imported. So after hitting enter plus shift here, you will get to the next input line here. But I'm not gonna go to the next input line because I want to write all these codes in this input line. Just to simplify the thing. It's not a big deal. Yeah. So this is the importing all the libraries here. Now we'll rather load the dataset. Okay. Yeah. Let's write it down. Now loading the dataset. That's the idea. Okay. Loading the dataset. Okay. So now the idea is we'll start with x train, y train. X train. These are train datas for x and y column. X, y datas. X train, y train. We'll basically load the MNIST dataset, then x test, y test, then x test, y test, so this will be common, x test, y test equals MNIST, that is the dataset, load, okay, MNIST dot load data. This is the idea. Oh, sorry, MNIST load underscore data, because since this is data, we are basically trying to load here. It will be underscore data, right? Well, So the next line will be, we have to normalize the data to 0, 1 range. In between the closed interval of 0 and 1, we have to normalize the data. Okay. Now normalize the data. We have to we have to normalize the data in the closed interval of 0 and 1. Okay, this is a closed interval. That means that is, more precisely, greater than equal or equal to 0 and this will be greater than or lesser than. And lesser than or equal to 1. Okay. So this is the idea. This is the meaning of the closed interval. Okay. Oh well. Now this, what are the codes for that? Okay. So basically we're going to normalize the data set here. So this will we have to normalize the X train data and test data. So let's start with the X train. X train equals X train dot H type. X train X underscore train equals X underscore train dot H type float 32. There should be, okay, there should be this part. Okay, the bracket will close here. Okay, so this is X train equals X train dot H type float 32/255. This is the idea. Okay. Similarly, let's copy this here. I just change, this will be Y train, X test rather, not Y train. This is the X data first. X test, it will be test. Since this is train data, this is test data, by normalizing both the data. Test so this is the X test data. Okay. Now the data, basically Y train data, now Y train and trace data. So one hot encode the labels. This will be here actually. So one hot encode the labels, yeah.
Here you will write y data, y trend equals two categorical that we have already imported in the library section, importing the library section.
Two categorical, yeah, I'm writing that.
Y trend. So it will be y underscore trend 10.
Okay, that's the idea. It should be like that. Then similarly we have to do it for y test data. So only test portion will be changed.
This should go there.
Okay. Now let's copy this thing.
Y test equals to categorical y test comma 10.
So that's the funda. That's the idea. Okay, yeah. Now these two parts are basically, you can see we have already loaded the dataset. Then you have to hit the enter plus shift here. Then you have to, you will load the datasets. Okay. Well, now we'll create the intended in the neural network models. So the thing is that, so one thing I want to mention here. You have to just hit enter and shift at this point here. Then you will get the output, or you will get to the next input line. But here I'm not going to the next input line. I'm just writing in this input line. So for that I'm just erasing this part what I've written. But the code that I'm gonna write after that will start basically after this line. Okay, so keep it in mind. Well, now we will
basically create the intended neural network model. Okay, so that's the idea. So let's create the neural network model. For that I have to write the codes. So for that, first let's define the model.
Since we are gonna do the sequential prediction, so let's start with this.
So we have to first define the model. So you have to first define the model. Which will be, so let's basically define the model. Since the model, what will be the model? Since we have decided to go for sequential prediction. Okay, so we'll define the model as sequential. So that's the idea. So the model will be it will be small letter. It will be
sequential. Okay. Okay, so that's the idea. Yeah.
Now after that, what we have to do, we have to flatten the input data, that is 28 by 28 images to 784 vectors that we are going to decide we are going to do. So let's do that. Flatten the input data. We are going to do 28 by 28 images. So flatten the input data. Oops, so I've already trained, so it should be like that. 22 by 28 images. Okay, then 784 vectors. Actually, so let's write this. This will be 784 vectors. Okay. Well, so for that we have to do what we need to do is basically we have to write the codes model. Oh, it will be small lettered. Model dot add flatten, again first bracket. This is the basically input layers. You can get it, input set. There are so many layers in the neural networks. Input layers, hidden layers, then output layers. Okay. These are input layers. Input set equals, as I have told here, 28 by 28 images. So it will be input set equal to 28 by 28. Okay. (28 by 28). Okay, that's the idea. You got it? Then let's add a hidden layer with 128 neurons and ReLU activation. Let's add a hidden layer. This is basically a basic model of neural networks that I'm showing you. You can write the codes for any neural networks. So any neural network. So I'm just showing it for a basic neural network. Okay. So we have already shown here the input layer. You can see. So now I'm gonna add the hidden layers. Okay. Since there are so many layers in the neural networks, firstly it will have input layer, secondly it will have hidden layers, then we will get to output layer. So it should be like that. So this is model.And. Now we are gonna add the hidden layer. So add a hidden layer. We are gonna add the hidden layer now with basically 128 neurons. I am designing these things like this. 128 neurons. This is the basic neural network models. 100 neurons and ReLU activation. Okay. Well, now for that what could we have to write? Model, then model dot, then I'm gonna add a hidden layer into it. That's why model dot add. In the bracket we are densing the layers. We are basically making it denser, making the neural network denser. That's why I will use dense. Okay, you got it? Dense. In the bracket it will be 128 comma the activation term equals ReLU LU.
Okay, so that's the idea. Now, so there are then the two types of layers are done now into the model, are being inserted into the model, have been inserted rather into the model. First is the input layer. The input layer is inserted in this section, in this part rather, and then the output layer. This will be this part, the hidden layer part. Here the input hidden layer is being added in here.
Now I will add the output layer. The output layer, which is add the output layer with 10 neurons. One for each class.
So here I'll put the softmax activation.
Okay. Or is a softmax activation, this activation, and for that the code will be like this. So model dot add, again dense, since I am I'm making it denser.
So dense
in the bracket 10, and the activation given here is
softmax.
So I have to put that also. Activation equals softmax.
Okay, so that's the idea. Now you have to hit enter plus shift.
Sorry, shift plus enter.
Yeah, something enter plus shift or shift plus enter. Then you will get shift plus enter rather. Then you will go to the next input line. Then the model will be created. So this is the model, the course for this model. Okay. Now I'm gonna erase this code here. Since I'm gonna write the next codes here. So the next code that I'm gonna write, that is basically I'm gonna compile the model. So that code will start after this cell. Okay. So these are consecutive cells. I'm just erasing just to write one by one cells here in the same input line. But you have to write it in the consecutive input lines one by one. Okay, you got it? Yeah. So I'm erasing this thing.
Now the step 4 is
compiling the model. So we will now compile the model.
Okay, the model is created now. Now we will go in. We will now compile the model. Compiling the model.
Okay. So compiling the model. This is the compiling the model. Yeah.
Now, to compile the model with an appropriate optimizer, we have to compile the model with an appropriate optimizer, loss function and matrix.
So here
we have to compile the model with an appropriate optimizer, loss function and
matrix. Okay, so we have to compile the model with an appropriate optimizer, loss function and matrix. Okay.
Now let's compile the model. So here the code will be model.compile optimizer equals Adam.
We'll start writing
Model dot model dot compile optimizer equals Adam. Yeah, model dot of compile optimizer equals Adam. Then loss function will be categorical cross entropy. Then the lost function will be categorical cross entropy. Okay. That's fine. Then matrix equals accuracy. Accuracy. Yeah. So these three things are being incorporated here. The optimizer, loss function and matrix. So you can see this is the optimizer, loss function and matrix. So there will be single apostrophe, single comma, and apostrophe single, it will be not double one. This is correction. Okay, so this is the code, this is the model, this is compiling, I am compiling the model. Okay, so that's the code. Now you have to hit shift plus enter to compile the model. Okay, I'm not doing that. I'm going to the next step, that is training the model. So now we have to train the model. Since we have created the model, we have then compiled the model. Now we are gonna train this particular neural network model that we have created here. So let's training the model. Training the model. Okay. Yeah. Now we have to train the model using the train data. Train the model. Now we have to train the model using the train data. Okay, so that's very interesting. Now to train the model, let's write the code model.fit x-train y-train. Okay, model x-train y-train, then epoch, yeah, I have set epoch train, right? Okay, so that should be 10. Then the batch size, batch underscore size is 32, and the validation split validation underscore split Variation speed is 0.2.
Okay, so that's it. Then
you have to hit shift plus enter, then the training of the model will be complete. Now let's go to the evaluating the model.
the final thing.
That is, we are gonna get the output. So evaluating the model. So this is evaluating the model.
So this is for evaluating the model, that is getting the output.
We have to evaluate the model using the test data. We have to
using the test data. Okay.
So we have to evaluate the data, the model rather, the created neural network model using the test data. And for that, let's write the code. The code is test underscore loss, then test underscore
Accuracy.
we have to get this both of them. Test underscore loss, test underscore accuracy
Equals
model. Since we are gonna
evaluate the model, so it will be model.evaluate model.evaluate
x test comma y test then print. We have to print the output. So print if test accuracy colon this is test accuracy colon
test
underscore accuracy,
and here will be another
comma this one.
okay. So oh god, no, that should be out. Yeah,
So that's the idea.
now you have to hit
Shift plus enter to get to the output, that to get to the sequential prediction.
okay. So
That's the neural network. So this is the code, step by step code
of this model that you have created here, of the new neural network model, which is the sequential prediction.
This is the basic neural network model, and I have shown the step-by-step course of how to write the Python course using the deep learning library, that is TensorFlow Keras for this neural network model of sequential prediction. We have created so again, just to summarize, the step-by-step course by using the Pythons. We have to write the codes using TensorFlow Keras for the intended neural network model. As such, the first step is basically have to install the TensorFlow by writing pip install TensorFlow. Then you have to import all the libraries, that is TensorFlow Keras, and then from TensorFlow Keras you have to import amino acid, the data set, then for models, the sequential, then layers, the dense pattern are basically being used as, since we are basically making the neural network model or architecture more and more dense or denser by inserting the layers, that is input layer, then hidden layers, then output layer, right? That's why we are using the keyword dense, or this because we are increasing the layers, making the layers dense. Then we have to import TensorFlow.Keras, the utils from this thing. You have to import to categorical. Then you have to, then the second step is basically this is the first step. You have to import all the libraries. Then the second step is you have to load all the data sets. Then you have to create the model. Then you have to compile the model. Then the models will be trained. After that, the model will be evaluated. That is, you will get the output results. It is like they write like this: a print a test accuracy underscore test underscore accuracy. So that's it. And then you have to hit shift plus enter to get to the output. Okay. So this is how you will write the codes for the Python codes for neural network models, your intended neural network models rather, by using the popular deep learning library TensorFlow Keras, right? So that's the idea. Now, so in this video we have shown how to write Python codes for neural network models, for our intended neural network models, by writing the code step by step, one by one. Okay, well, so let's erase this thing. Now let's try to understand what are TensorFlow and Keras a little bit. Okay, well, now TensorFlow, Keras are very powerful tools, basically widely. These are deep learning library. Now these are widely used for building and training machine learning models, especially deep learning models. Now let's explain this TensorFlow and Keras a little bit. Okay. Now TensorFlow is basically an open source machine learning framework. As we know, it's developed by Google Brain. It provides a comprehensive ecosystem of tools, libraries also, and community resources that allow researchers and developers to build and deploy machine learning models with ease. Very easily it can deploy and develop or build the machine learning ML models. It helps, this deep learning library helps us or researchers to do so. So there are some, let's point out some key features of TensorFlow also. So let's talk about 4 such key features of TensorFlow, which are flexibility, scalability, ecosystem, and community and support. So let's first talk about flexibility of this TensorFlow. So TensorFlow basically supports various machine learning or ML or deep learning or DL algorithms. It can be used for both research and production environments. So it's very, very important. As you can see, I have shown all these things. I have used basically the deep learning
techniques, deep learning libraries are there. In this particular code that I have just written, I have used TensorFlow, Keras, libraries, deep learning libraries. Now the scalability. Let's go another feature of the TensorFlow, that is scalability. And the scalability is also very important. Why? Because TensorFlow can run on multiple machines, multiple CPUs, GPUs and TPUs, making it highly scalable for mobile devices, from mobile devices to large scale distributed systems. This is very important. Also, ecosystem, if you talk about another key feature of TensorFlow, that will be ecosystem apart from flexibility and scalability. Now TensorFlow includes a suite of tools such as TensorFlow Extended TFX for end-to-end machine learning pipelines. This is very important. What is end-to-end machine learning pipelines? I'll explain later in my video. Another video I will explain. I make another video on this topic. There is end-to-end machine learning pipeline. This is very important. Also TensorFlow Lite. So in today's world, the social media Lites that uses lesser, and that has very lesser size. That is Facebook Lite, Instagram Lite, other lights. So those are basically very it has its weight, its size is much lesser than the bigger file that is Facebook for Android or Instagram, bigger applications, Android applications. So similarly here, the deep learning library TensorFlow, it has also TensorFlow Lite for mobile and embedded devices, and TensorFlow.js for running machine learning models in the browser. Okay. That's why the ecosystem is also important, also a key feature of TensorFlow. This is the deep learning library. Now then another one, the community and support. This is another very important key feature of TensorFlow. Which basically TensorFlow has a large community and support, community and extensive documentation, tutorials and examples to help users at all levels. You can learn it. You can go to the TensorFlow site, the Google Brain. It's basically an open source machine learning framework. It's developed by Google Brain. You can go to their site. You can browse those things on internet, and you can you will have a very big, larger community, very large community, and because since it has a wide application all throughout the world, so it will have it has rather extremely large community, and they are very supportive also. Okay. If you have any question, if you are having some issues using these deep learning libraries, TensorFlow or Keras, when you are writing the Python codes for these neural network models or other things, so you can directly report them to the community. You can, and they will they hopefully they will resolve the issue, because it is a very large community. So somehow someone out there in any corner of the world, they will engage you and correctly. They will get you correctly, and they will basically try to help you with the example, with the answer. So, and also it has in all possible levels, from beginner to advanced levels and the intermediate levels. The community and support staffs, they support each other very well. Okay. Now, so that's all about TensorFlow. Now let's talk about Keras. Now Keras basically is another high-level neural network API. Is basically high-level neural network API written in Python that runs on top of TensorFlow. It's very important. So in this code that I have shown, I have used both TensorFlow and Keras, right? So TensorFlow is basically an open source machine learning framework developed by Google Brain. Now Keras is basically high-level neural networks API written in Python that basically runs on top of TensorFlow. Now it's designed to enable first experimentation, very speedy experimentation with deep neural networks, and is very much user friendly. I have used so many times, and is modular and extensible also. So these TensorFlow and Keras, I have used both. I've written the Python course. I've written the Python course using these two things, TensorFlow and Keras, this library and this API.
So this is very important also, and there are some, let's point out, just to understand properly, let's point out some key features of Keras also. Now the first key feature of Keras is basically like TensorFlow, it is very much user friendly. The Keras provides us basically a simple and consistent interface optimized for quick development and easy debugging. So whenever you need to debug something, suppose you have got some bug out there anywhere, when you're writing the codes. So if you want to debug it easily, and the quick development also, you can use it. You can use Keras as well as in TensorFlow. So it is extremely user friendly. And then modularity, another key feature of Keras, which are basically Keras models are made by connecting building blocks such as layers, optimizers and activation functions, allowing for easy customization as well. This is key feature, modularity, because these models are made by connecting building blocks. There are so many layers. So why this is important? Let's explain a little bit. See, when you are talking about neural networks, right? Neural networks are basically artificially built up, the artificial group of human neurons, not human neurons, the artificial, it mimics the human neurons actually. It's artificial group of neurons actually. Or more precisely, in the proper choice, a precise choice, a more precise choice of words will be the group of artificial neurons, right? Its architecture, I have explained a little bit. Its architecture is basically, it may be easy, it may be complicated. So let's point out a little bit. As I let's hit it again. The neural networks, it comes with three types of layers. Firstly, it will have an input layer. Okay, it will have nodes, the input layer, and nodes in the input layer. Then it will have one or multiple hidden layers. Then it will have output layers as well. Okay. Then in the output layers, we'll have the output. Now the in between steps, the hidden layers, all the calculations are done in those particular layers. And the idea is, if you actually try to design a neural network or a neural computer, then you have to get all the nodes in the input layer. Then all the nodes, those will be transferred to the hidden layers, one or multiple hidden layers. Then it will have all the calculations done in between in those layers. Then it will go to the next output layer in a consecutive manner, and then output layer will yield the outputs. So that is very important thing. So you can see this model, there are so many models, so many layers, the building blocks you can see, right? So those building blocks are easily explained or easily connected by this Keras API. This API is basically written in Python. It's full Python, 100% Python. It's written in 100% Python codes. It's very important. Now let's talk about integration. This is another key feature of Keras. Now, while Keras started as a standalone library, it's now part of the TensorFlow core library also. So it basically started, when it started working, it was a standalone library. Now it is a part of core TensorFlow library. Now it's basically making, so since this is a part of core, TensorFlow library, it's making it seamlessly integrated with TensorFlow's capabilities. This is very important. Another part, which is extensibility. Now users can easily write custom building blocks for new research ideas. This is the key feature of Keras. This is extensible. This is very, very important. So the key features of TensorFlow, there are four key features I have already explained for TensorFlow, which are flexibility, scalability, ecosystem, and community and support. And Keras also have I will explain 4 key features of Keras, which are user friendly, modularity, integration and extensibility. Okay. Now since these two are different, not same, now let's explain how those two work together. Since you have seen in this course that I've written the codes, Python course for neural networks model of sequential prediction. I've written this code, so there I've used both TensorFlow and Keras. Now the question is how those two work together, since TensorFlow is an open source machine learning framework developed by Google Brain. Now Keras is basically an API, neural network, high level neural network API written in full Python. Now how those two things work together, TensorFlow and Keras. Now Keras provides an intuitive interface for building neural networks and other machine learning models, while TensorFlow handles the back-end computation. So this is very, very important. Keras provides an intuitive interface for building neural networks. This is very important. And other machine learning models. Why? TensorFlow handles the back-end computations. You got it? This is very important. Now this combination of these two things, TensorFlow and Keras, allows us, the users, to build complex models, complex neural network models or other models, without dealing with the neural network models without dealing with the lower level details of tensor operations and optimizations. This is very, very important. So how do those things work together? Because basically let's explain a little bit again. So Keras, which is actually the API, high level neural network API written in full Python. It provides us an intuitive interface for building neural networks, okay, and other machine learning models, while TensorFlow handles the back-end computation. This is very important. Now both the Keras and TensorFlow, they give us the opportunity, give the users the opportunity to develop complex and more complex models without dealing with the lower level details of tensor operations, okay, and optimization. This is very important. Okay. So this is how these two open source machine learning framework, the TensorFlow and the API, high level neural network API in full, that is basically full Python. It is written in full Python. These two things, TensorFlow and Keras, they work together like this. Okay. So today in this video, what we have learned, I have shown how to write step-by-step Python codes for any intended neural network models, and I have explained Keras and TensorFlow. I have used Keras and TensorFlow both in the codes. These are the deep learning libraries, TensorFlow, okay, and Keras. This is the API, and I have explained how those two, TensorFlow and Keras, work together. Okay, hope you have enjoyed the video. Hope you have learned something new from this video. Let's meet in the next video. Till then, bye.